The National Electrical Code, or NEC, is not inherently a set of laws in itself. It is a comprehensive set of standards and guidelines for safe electrical installations. However, its practical effect often mirrors that of laws when a state, county, or city formally adopts it as the basis for their local electrical regulations. When a jurisdiction adopts the NEC, it incorporates the code's provisions into its legally enforceable requirements for electrical work within that area. This adoption process transforms the NEC from a mere set of recommendations into a set of rules with legal standing. Think of it like this: the NEC provides the detailed specifications, and the adopting jurisdiction provides the legal framework that makes those specifications mandatory. In essence, the NEC power comes from its adoption and enforcement by governmental bodies. It is these governmental entities that give the NEC its teeth. To further illustrate the relationship between the NEC and legally binding requirements, consider the structure of laws and regulations at different levels of government. States, for instance, enact laws governing a wide array of activities, including driving. Similarly, counties and cities create ordinances that dictate what is permissible within their boundaries. These laws and ordinances are directly enforceable by the respective governmental bodies. When a state or local government adopts the NEC, it essentially elevates the code's status to that of a local law or regulation. This means that electricians, contractors, and other individuals performing electrical work must adhere to the NEC requirements, or they will face potential legal consequences such as fines, permit revocations, or even criminal charges in some cases. The degree of enforcement and the specific penalties for non-compliance can vary depending on the jurisdiction. Some areas may have stricter enforcement mechanisms than others. It's also important to note that jurisdictions may adopt the NEC with amendments. This means that they may modify certain sections of the code to better suit local conditions or priorities. These amendments then become part of the legally enforceable electrical regulations within that jurisdiction. Therefore, it's crucial for anyone working with electricity to be aware of not only the latest edition of the NEC but also any local amendments that have been adopted. To understand the legal implications of the NEC, it's helpful to consider some practical examples. Imagine that a city adopts the NEC with no amendments. In this scenario, all electrical installations within the city must comply with the code's provisions, such as those governing wiring methods, grounding, overcurrent protection, and equipment installation. If an electrical contractor installs wiring that does not meet the NEC standard, the contractor could be subject to fines or required to correct the installation. Now imagine that a county adopts the NEC but amends a specific section related to the type of wiring allowed in residential buildings. In this case, electrical contractors working in that county must comply with the amended version of the NEC, not the original version. This could mean that they are required to use a different type of wiring or follow different installation procedures than they would in an area that has not amended the NEC. The NEC legal standing is further reinforced by the fact that it is often referenced in construction contracts and insurance policies. For example, a construction contract may specify that all electrical work must be performed in accordance with the NEC. Similarly, an insurance policy may require that electrical systems meet NEC standards in order to be covered. These contractual and insurance requirements create additional incentives for compliance with the NEC. It's also worth noting that the NEC is updated every 3 years. This ensures that the code remains current with the latest technological advancements and safety practices. When a new edition of the NEC is released, jurisdictions typically review it and decide whether to adopt it. The adoption process can take time, so it's important to be aware of which edition of the NEC is currently in effect in your area. In summary, while the NEC is not a law in and of itself, its adoption by governmental bodies effectively transforms it into a set of legally binding requirements. Compliance with the NEC is essential for ensuring electrical safety and avoiding potential legal consequences. It is important to stay informed about the latest edition of the NEC and any local amendments that have been adopted in your jurisdiction. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. Understanding these topics is crucial for anyone working with electricity. Wiring methods refer to the types of conductors and raceways that are allowed for electrical installations. The NEC specifies the types of wiring methods that are suitable for different applications and environments. Overcurrent protection refers to the use of fuses and circuit breakers to protect electrical circuits from excessive current. The NEC specifies the size and type of overcurrent protection devices that are required for different circuits. Grounding refers to the connection of electrical systems to the earth. Grounding helps to prevent electrical shock and reduce the risk of fire. The NEC specifies the grounding requirements for different types of electrical systems. Equipment installation refers to the proper installation of electrical equipment such as lighting fixtures, appliances, and machinery. The NEC specifies the installation requirements for different types of equipment. Special occupancies refer to locations that have unique electrical requirements, such as hospitals, hazardous locations, and swimming pools. The NEC specifies the electrical requirements for these special occupancies. The NEC is organized into chapters, articles, and sections. Chapters cover broad topics such as general requirements, wiring and protection, and equipment. Articles cover more specific topics within each chapter. Sections provide detailed requirements for specific situations. To effectively use the NEC, it's important to understand its organization and how to navigate it. The NEC also contains informative annexes which provide additional information and guidance. These annexes are not part of the enforceable requirements of the code, but they can be helpful for understanding and applying the code's provisions. The NEC is a complex and comprehensive document. It's essential to have a thorough understanding of the code to ensure electrical safety and compliance. Continuing education and training are crucial for staying up to date with the latest changes to the NEC and best practices for electrical work. Many organizations offer NEC training courses and resources. These courses can help you to understand the code's requirements and how to apply them in real-world situations. The NEC is a vital tool for ensuring electrical safety. By understanding and following the code's provisions, you can help to protect yourself, your colleagues, and the public from electrical hazards. Remember that electrical work can be dangerous. Always take precautions and follow safe work practices. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical safety is everyone's responsibility. By working together, we can create a safer electrical environment for all. The NEC is not just a set of rules, it's a framework for ensuring that electrical systems are designed, installed, and maintained in a safe and reliable manner. It's a foundation for protecting lives and property from the hazards of electricity. The NEC plays a crucial role in preventing electrical fires, shocks, and other electrical accidents. It helps to ensure that electrical systems are able to operate safely and efficiently. The NEC is a dynamic document that is constantly evolving to reflect the latest technological advancements and safety practices. It's important to stay informed about the latest changes to the code to ensure that you are using the most up-to-date information. The NEC is not a substitute for good judgment and common sense. It's important to use your knowledge and experience to make informed decisions about electrical safety. If you are ever unsure about something, consult with a qualified electrical professional. The NEC is a valuable resource for anyone who works with electricity. By using the code effectively, you can help to ensure electrical safety and compliance. Remember that electrical safety is a continuous process. It's important to stay vigilant and to take precautions to protect yourself and others from electrical hazards. The NEC is a guide, but it is up to the electrician to ensure compliance with the code and safe work practices. One must understand how to apply and interpret the NEC and its various tables. For example, NEC Table 310.16 provides opacity ratings for conductors. It is critical to understand how to apply the correction and adjustment factors found within the table to ensure conductors are appropriately sized. Consider a scenario where you have 3 current-carrying conductors in a raceway at an ambient temperature of 86 degrees Fahrenheit. According to NEC Table 310.16, a 12 American wire gauge copper conductor with THHN insulation has an ampacity of 30 amps. However, you must apply adjustment factors if there are more than 3 current-carrying conductors in a raceway. In this case, there are only 3, so that is not an issue. Temperature correction factors must be considered as well. If the ambient temperature is 104 degrees Fahrenheit, you have to look up the correction factor for THHN insulation at that temperature, which is 0.91. Therefore, the adjusted ampacity of the 12 American wire gauge copper conductor is 30 amps times 0.91, which equals 27.3 amps. This means the conductor can only safely carry 27.3 amps in that environment. It is also essential to understand overcurrent protection. The NEC requires that conductors be protected against overcurrent. This means that the overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the conductor from overheating and potentially causing a fire. The general rule is that the overcurrent protection device should not exceed the ampacity of the conductor it is protecting. However, there are exceptions to this rule, such as when the conductor is part of a motor circuit. For example, a 14 American wire gauge copper conductor with THHN insulation has an ampacity of 15 amps. Therefore, it must be protected by a 15 amp circuit breaker. However, if the conductor is supplying a motor, the overcurrent protection device may be sized larger than 15 amps depending on the motor's characteristics. Grounding and bonding are also very important for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and to energize the circuit. Bonding ensures that all metal parts of an electrical system are electrically connected, which helps to prevent voltage differences and reduce the risk of electric shock. The NEC specifies the grounding and bonding requirements for different types of electrical systems. It is important to follow these requirements carefully to ensure electrical safety. Another critical aspect of the NEC is its requirements for working space around electrical equipment. The NEC requires that there be sufficient working space around electrical equipment, such as panel boards and switchboards, to allow for safe access and maintenance. The amount of working space required depends on the voltage of the equipment and the location of the equipment. For example, the NEC requires at least 3 feet of working space in front of electrical equipment that operates at 600 volts or less. The working space must also be clear of obstructions and must be properly illuminated. These working space requirements are in place to protect electricians and other workers from electrical hazards. It is important to comply with these requirements to ensure a safe working environment. The NEC also addresses specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. These occupancies have different electrical needs and hazards. The NEC provides specific requirements for each type of occupancy. For example, the NEC has specific requirements for the installation of ground fault circuit interrupters, or GFCIs, in residential bathrooms and kitchens. GFCIs are designed to protect people from electric shock by interrupting the circuit when a ground fault is detected. The NEC also has specific requirements for the installation of emergency lighting in commercial buildings. Emergency lighting is designed to provide illumination in the event of a power outage. These occupancy-specific requirements are in place to address the unique electrical needs and hazards of each type of occupancy. Staying updated on the latest edition of the NEC and any local amendments is crucial. The NEC is revised every 3 years, and local jurisdictions may adopt the latest edition with or without amendments. It is essential to be aware of the edition of the NEC that is in effect in your area and any local amendments that have been adopted. You can find this information by contacting your local building department or electrical inspector. You can also purchase a copy of the NEC from the National Fire Protection Association, or NFPA. Staying informed about the latest changes to the NEC is important for ensuring compliance and electrical safety. The NEC is a complex and comprehensive document, but it is an essential tool for anyone who works with electricity. By understanding and following the code's provisions, you can help to ensure electrical safety and protect lives and property from electrical hazards. Remember to always consult with a qualified electrical professional if you have any questions or concerns about electrical safety.